Hey guys, Mr. B here. In this video, we're going to be going over the practice problems in the chapter 10.3 notes. So if you had any questions, hopefully this video will help you. All right, let's get started and jump into number one here. So it says, when a 14.2 gram sample of mercury 2 oxide is decomposed into its elements by heating, 13.2 grams of mercury is obtained. What is the percent composition of the compound? All right, so I'm going to kind of write this out first so you understand what is the information they're giving us, and then we'll go into how do we solve, okay? So we have 14.2 grams of this mercury 2 oxide, and it's being decomposed. That means it's breaking apart into the elements that it's made of, which would be mercury, and they're telling us that we're getting 13.2 grams of mercury, and of course oxygen, which they're not telling us how much oxygen we have. Okay, so it's going to look something like this. So we have 14.2 grams total of the sample. It breaks apart. 13.2 grams of mercury is left over, and then some amount of oxygen, which we don't know. And they want us to determine what percentage of this compound is mercury and what percentage of this compound is oxygen. All right, so in order for us to do this, we're going to have to take the total mass, which they're giving to us. Okay, so 14.2 grams. And we're going to take each individual element's mass that they're giving us in the problem, divide that from the total, and then times 100 to get a percentage. Okay, so we're going to take 13.2 grams of mercury, divide that by 14.2 grams of the total, and then times that by 100 to get a percentage. And let's do this on a calculator to make sure that we get accurate answers here. So 13.2 divided by 14.2 times 100. And we'll round to, I guess, three significant figures. So we get 93.0% for the mercury. And then as for the oxygen, to figure this one out, there's two ways we can do this. One, since we now don't know that 93% of it is mercury, we can take 100% minus 93%, and the difference is going to be the percentage of oxygen. Or we can take the total mass here that we're starting with, subtract the mass of the mercury we made, and the remaining mass that we're missing is going to be the mass of the oxygen, because the law of conservation of mass says so. And then when we have the mass of the oxygen, we can put it in here just like we did before to get that percentage. Okay, so I'm going to do that route just because we can. If you want, though, you can do 100% minus 93 and get it that way in a much shorter amount of time. So let's go 14.2 grams minus 13.2 grams. This gives us, of course, 1 gram of oxygen in our compound. So if we set this up, so 1 gram of oxygen, divide by 14.2 grams of the whole compound, and then times it by 100. Hopefully we will get about 7%. So let's see, 1.0 divided by 14.2 times 100, and we get 7.0%. So again, there's two ways to do it. I did it the longer route in this way. If you wanted to do 100% minus 93% and get 7, you could have done that just fine. Like I said, I just wanted to show one other way to do it. So, all right, so there's problem number 1. There's our percent composition. Let's move on to problem number 2. All right, so this one says a sample of a compound analyzed in a chemistry laboratory consists of 5.34 grams of carbon, 0.42 grams of hydrogen, and 47.08 grams of chlorine. What is the percent composition of this compound? All right, so basically they're telling us that we have 5.34 grams of carbon. Let's make sure this isn't underlined. 5.34 grams of carbon plus 0.42 grams of hydrogen plus 47.08 grams of chlorine. And when you add all these together, you get some compound. And it has a chemical formula, I'm guessing, of C something H something Cl something. Okay, and we don't know how many grams of this we're making because they're not telling us. Okay, but this is basically all the information that we know. And they want to, again, have us determine what is the percent composition. So what percent of this is carbon? What percent of this is hydrogen? And then what is the percentage of this for chlorine? Okay, now for this one, it's sort of like the first problem that we just did. Only in this problem, they told us how much in the material that we had to start with. And in this problem, they're not telling us how much we have the total thing. They're telling us all the individual parts. So first thing is we need to get a total mass. And we can do that just by adding together all of the masses that they're telling us. Okay, so we need to get a total. So 5.34 plus 0.42 plus 47.08. So I get 52.84 grams. Okay, so that's our total. That's this compound here. So 52.84 grams. Oh, grams. All right. Then to find out percentages for each element, we're going to take the individual mass of that element, which they're giving to us, divide by the total times 100, and we'll get our percentage. Okay, so 5.34 grams of the carbon, divide by 52.84 grams of the whole compound, times that by 100. So let's do this on a calculator real quick. And we will round to 3 sig figs, I suppose. So 10.1%. 10.1% for the carbon. For the hydrogen, we have 0.42 grams divided by 52.84 grams, and then times 100. It's probably going to be a pretty small percentage would be my guess, because that's not very many grams. Times 100. All right, so we get 0.795% for the hydrogen. And then for the chlorine, we're going to take our 47.08 grams, divide that by, again, 52.84 grams times 100. And this is probably going to be the largest of all the percentages because it's making up the most of the compound. And again, rounding to 3 significant figures, we get 89.1% for the chlorine. Okay, now if we add all these together, 10.1 plus 89.1 plus 0.795, we should get about 100%. And if I do this out on my calculator, I get 99.995. It's basically 100, okay, just because of rounding. So if our percentages add up to 100, we know we did it right. All right, cool. So there's number 2. Let's take a look at number 3. So this one says, calculate the percent nitrogen in these common fertilizers. All right, so for this one, we're not finding the percent composition of the whole compound. We're just finding the percentage of the nitrogen. Okay, now in order to do this, we still need to know what is the total mass of the whole compound, which, since they're not giving us any numbers, we're going to have to use molar mass. Okay, so you got to find the whole mass of the whole compound, which is molar mass. Then we'll use the mass of just the nitrogen, divide by the total to get just the percentage of the nitrogen. Okay, so we have to add together an N and 3 H's. All right, so let's go switch over to a periodic table here real quick. If you have one on hand, perfect. If not, you might want to pause the video and go get your periodic table. We're going to use it for other problems too. So nitrogen here has a mass of 14.007. We'll just say 14 to keep it easy. And hydrogen has a mass of basically 1. So 14 grams for the nitrogen and 1 gram for the hydrogen times up by 3 because there are 3 of them. So this gives us a total molar mass of about 17 grams per mole. Okay, so there's our total molar mass. And then they just want us to find percent nitrogen. So we're going to take the percent, the mass of the nitrogen by itself, so that was 14 grams for this compound. Divide that by the total mass, which is 17 grams, then times up by 100 to get our percentage. Okay, so 14 divided by 17 times 100. And I guess we'll just round to whole numbers to keep it easy. So this is about 82% nitrogen in that compound. Okay, so there's that one. Let's take a look at the second one here. Ooh, I don't want to bold that. Okay, so for the second one, put a space in between here too. We have NH4NO3. All right, so again, we need to find the total molar mass, and we're going to have to add together a lot of elements. So they have nitrogen in 2 different places here. It's still just 2 N's though total. So we're going to add 2 N's together. We are going to add 4 H's, and we're going to add together 3 oxygens. Okay. All right. So nitrogen already learned 14 grams. We just did that on the previous one, so we can do that one pretty quick. So that's 28 grams. Hydrogen we also looked up. That's 1 gram a piece. There's 4 of them, so that's 4 grams. And then for the oxygen, let's go look real quick just to make sure we remember what oxygen's molar mass is. Oxygen is 15.999. It's basically 16. So back to our notes here. 16 grams times that by 3. And I'm going to do this on a calculator just to make sure that I don't mess up with the mental math. Okay, so 48 grams. So our total molar mass is going to be equal to 48 grams plus 4 plus 28. So this gives us a molar mass of 80 grams per mole. And then to find the percentage of the nitrogen only, we're going to take the mass of the nitrogen, which in this case is 28 grams. Okay, so this is the total mass of the nitrogen in the compound, 28 grams. Divide that by the total mass of 80, and then times that by 100 to get a percentage. So 28 divided by 80 times 100, and we get a nice even 35% nitrogen in that compound. All right, so there's problem number 3. All right, final one here, problem number 4. So it says, from the formula for calcium acetate, which they're giving to us, calculate the mass of carbon that can be obtained from 65.3 grams of the compound. All right, so this one's a little bit more challenging because they want us to determine how much carbon is in just 65.3 grams of this material. So to do that, we're going to need to know what is the percent of the carbon in that compound, and then apply that to the 65.3 grams. Okay, so we have 65.3 grams of this material. Okay, and again, the question is, what amount of grams is carbon? So what amount of that 65.3 grams is just grams of carbon? Okay, all right, so to do this again, we're going to need to know percent composition because we want to know what is the percentage of the carbon in that compound, and then we're going to apply that percentage to the 65.3 grams. Okay, so we're going to need to know molar mass first. So we have mass of calcium. Now for this, remember that this 2 is going to multiply everything in the parentheses. So there's technically 4 carbons, 6 hydrogens, and 4 oxygens. So when we add together these to find the molar mass, we need to remember to add the right amount of each of these, okay? All right, so let's go look up calcium real quick. I don't know that one off the top of my head. So calcium has a molar mass of about 40 grams per mole, right? So let's add that to our notes here. So 40 grams for the calcium. And there's only one of them. Carbon we did on previous ones, so we know that that's 12 grams. We're going to times that by 4. I'm going to do this on a calculator just to make sure I don't mess up with the mental math. Okay, so that's 48 grams for the carbon. Hydrogen we know is 1 gram a piece. We're going to times it by 6. So that's 6 grams for the hydrogen. And then oxygen we know is 16 grams. We did that also on a previous problem. And that gives us 64 grams for the O. All right, so those are all the individual masses. Of course, we need to add these together to get a total molar mass. So let's go 40 plus 48 plus 6 plus 64. So I get 158 grams per mole for our total molar mass. All right, so now that we know the total, we can find what percentage of this is carbon by taking the mass of the carbon divided by the total mass times 100, and then we'll apply that percentage to the 65.3 grams to figure out how many grams of carbon are in just that sample. Okay, so we're going to take 48 grams for the carbon, divide by 158 grams for the whole thing, and then times 100 to get our percentage for the carbon here. Okay, so 48 divided by 158 times 100. Let's round to 3 significant figures because this 65.3 has 3 significant figures. So I get 30.1% of this is carbon. Okay, so 30.1% of this whole compound is carbon. So of the 65.3 grams, we're going to apply that 30.1%. And to do that, we're going to take 65.3 grams times the 30.1% as a decimal. So that is going to be 0.301. Okay, so to turn a percentage into a decimal, we just move that decimal point 2 places to the left. So 30.1, we're going to move that over to make it 0.301. And then when we do this math out, the number of grams we get here is going to be just the grams of carbon. So I get 19.7 grams of this will be only carbon. Okay? And actually, yeah, let's leave it as is. All right. So this is our final answer right here. Okay, of the 65.3 grams, 19.7 grams of it would be carbon because 30.1% of it is carbon, and we can apply that to the 65.3. All right, so hopefully those questions make sense, and hopefully that helped you. But again, as always, if you're still confused, you need more help, or you need more review, please reach out to me, and I have no problem helping you. All right, guys, that's it for this section, and I will see you in the next video. Bye.